For today, I'm not going to switch my screen for just a minute. For today, we may not get through all the notes that we're supposed to, so may have to readjust your homework. So don't immediately do your homework. I know that sounds crazy, but let me check which ones we get through if we don't get to where we need to go. All right. Remember, your homework is how I'm giving you your participation grade or whatever your absence is. I don't want you to be behind. Everybody is good so far. So right now you need to make sure that you have for today, Monday and Tuesdays of last week turned in. Guys, please don't wait though. Don't get behind. Try to catch up if you're already behind. Okay. All right. So now I'm going to share my screen and we're going to go ahead and get started. And if y'all have any questions, y'all just jump in and ask. That's not a problem. So again, starting 1.2 today. And if we have to readjust, we will. I'll do the best I can to give you time to do that homework. And we may just have to cut that homework down. I'm sure you're real sad about that, but we'll get to it. Okay. First thing is all these dots just tell you what you're going to learn in this section. And then we're going to go ahead and get started. To display the distribution of a categorical variable, use a bar graph or pie chart. So this is categorical. That means it's not numbers. How can we picture the distribution of quantitative data? And that should be a question mark. So one of the simplest graphs to construct and interpret is a dot plot. And so I told you guys to do that airplane activity, and I hope you've done it. If you hadn't, you need to go do it today. Remember, that's just placing those slips in a hat and pulling them out and saying the number of females. It's really quick, so it's not going to take very long at all. So I want to have that in today, please. So each data value is shown as a dot above its location on a number line. And we'll show how to make a dot plot using some sports data. Okay, this little section that we're doing today is not very hard. Dot plots are pretty easy. So then here's some numbers, and it just says make a dot plot of the data. So look at your lowest compared to your highest. What's your lowest number on this set of data?
0.
0. So I'm gonna put an L above that. That's my lowest. What's my highest?
14.
14.
All right. So my number line needs to go from 0 to 14. So when I make this number line, and I'm drawing it, but you can't see it, I'll move it in just a second, okay? All right. Is everybody good? I didn't cover anything up. All right. So here's my number line. I'm going to start at 0. I'm going to go to 14. I don't care how you do it in between there. I did by 2s. It might look weird in just a minute. 2, 4, 6, 8, 10, 12. That wasn't too bad. 10, 12, 14. And then you can do the little numbers in between. That's fine. I don't care. I just don't like writing out a million numbers. So you can do it however you want to. So then what you got to do is look, how many 1s do you have? I mean, how many 0s do you have?
1.
So we're going to put that right there, just like that. So when you move on to your next category, how many 1s do you have? Come on, guys. How many? 3. 3. Make sure you line up these two horizontally. And then 2, 3. And then I'll mark out all the 1s. How many 2s do you have?
6.
Yes. Try to line them up horizontally. And then mark out all your 2s. 2, 2, 2, 2, 2, 2. And you keep doing this. How many 3s do you have?
3. Or 5.
5.
1, 2, 3, 4, 5. Again, line them up horizontally the best you can. 3s. How many 4s do you have?
7.
Yep. And again, trying to line them up horizontally. This is where graph paper comes in handy. That's what I told you. If you're a neat freak, use the graph paper. It'll make it easy. Okay. What else do we have?
5.
Just 1 5. And then the only thing we have left is a 13 and a 14. So we're going to put a 13 and a 14. And that's it. That's your dot plot. Any questions on making a dot plot? All right. Making a graph should say not. You'll see as we go through, that's going to get worse and worse. Okay. So all my typos will get worse and worse. The purpose of a graph is to help us understand the data. So it's not an end to itself. It just helps us understand data. After you make a graph, always ask, what do I see? Here's a general strategy for interpreting the graphs of quantitative data. So it's not enough just to have the graph, you have to interpret it as well. So you can't just look at it and be like, oh, okay, graph done. You have to tell what's going on in the graph as well. Okay.
Can you make the paper down?
This way? This way.
No, I mean up. Yeah.
Sorry, I always get confused when y'all ask.
Yeah, you're good.
You good?
Yeah.
Okay. All right, how to examine the distribution of quantitative variable. In any graph, look for the overall pattern. And we'll talk about that soon. And for striking departures from that pattern. Striking departures from that pattern are outliers. You guys know what outliers are. So in this graph, which ones look like outliers?
13 and
13 and 14, because they're not up there. And then we're going to talk about like this overall pattern, like what this shape is and stuff like that. So we'll get there in just a minute, okay? You can describe the overall pattern of a distribution by its shape. This is important. You will do this the rest of the year, okay? Shape, center, and spread. An important kind of departure is an outlier. I just told you that, which is an individual value that falls outside the overall pattern. I'm gonna give you a chance to catch up because I know I went through that quick. So the big thing you need out of this is to describe, you need shape, center, spread, outliers. Shape, center, spread, outliers. And again, you'll be doing that the rest of the year, like no joke, the rest of the year. All right, you'll learn more formal way of describing shape, center, and spread. And identifying outliers soon. For now, let's use our formal understanding of these items or ideas to examine the graph of the U.S. women's soccer data. So the shape, and the way they do this is they make it like, they say SOCS, S-O-C-S. Okay, but I don't ever do it. I leave it just like this, shape, center, spread. And then you have outliers. Again, if you want to do SOCS, you can do that and throw outliers in between shape and center, but I always do it at the end. Shape, center, and spread. This is the overall shape of a graph. And basically what this is we're going to determine if it has any skew. So is it right skewed, is it left skewed, or is it approximately normal? Center is the center of the graph. And you don't have to write any of that down. We're going to get to it. So I'm just trying to give you a heads up of what it's going to be. The center of the graph is either going to be the mean or the median. It depends on the type of graph. And then the spread is how far the data reaches. And that's either going to be the standard deviation or the IQR. And IQR is interquartile range, and you did that in Math 1. So again, it's not hard work. It's just stuff you haven't done in a while. And that's it for this. That's all for this page. So we're going to flip over. There's not much on the next page either. Okay. Is everybody good with this page? If you're not, just say you're not. All right. So interpreting a dot plot, the EPA is in charge of determining and reporting fuel economy ratings for cars. Think of those large window stickers on a new car. I don't know if you guys have ever seen those or not. For years, consumers complained that their actual gas mileages were noticeable, it should say noticeably lower than the values reported by the EPA. It seems that the EPA's tests, all of which are done on computerized devices to ensure consistency, did not register or consider things like outdoor temperature, use of air conditioner, or realistic acceleration and braking by drivers. In 2008, the EPA changed the method for measuring a vehicle's fuel economy to try to give more accurate estimates. Now, that really doesn't have anything to do with it. It just tells you background. Okay, so we're just looking at this. These are the models 24 of the 2012 midsize cars. So my question is, what are your individuals?
Models of the car.
Of what kind of cars?
2012 mid-size car.
Perfect. Make sure you say all of it. So there it is. It says describe the shape, center, and spread of the distribution. Are there any outliers? Okay, so here's what we're going to do. I'm going to teach you how to make one on your calculator. So go into your stat. So go into stat and edit. I hope you have it. And take a minute to put these in. And it does take a minute, and you will have to do this a lot at times. So
Go into stat and then what?
edit.
We put them all into L1, or should you split up L1, L2, L3?
L1. All right, so I'm not going to show you a dot plot because your calculator doesn't do dot plot, but it'll do your histogram or your bar graph, which is fine. I'll show you exactly what that looks like. And then you can kind of tell. So remember, it displays your counts as well. And let me see if this is in your book while I'm looking here. All right, does everybody have those in there?
Yeah.
Okay. 1.2. I'm going to go ahead and show you how to make a histogram, so that way when we get to it, it's going to be a lot easier. You're going to go to second y equals. Second y equals. You're going to hit enter. And then right now I'm going to make a histogram. I'm not making the dot plot. I'm going to show you how to make that. You can make those by hand, but they're not going to ask you to make them. But we're about to do histograms, so I'm going to show you how to do that. So once you highlight that bar graph right there, hit zoom 9, because that's zoom stat. We're in stats class. And so that'll make a histogram. And we'll see that in a minute, and it kind of gives you the same idea. Dot plots just take too long to make, and you don't want to make them, if that makes sense. Is everybody good? All right, so I'm going to.
Can you repeat that one more time?
What
How
part?
to make that graph?
Okay, yeah.
Now when I
Second y equals, and you're gonna hit enter, and that comes up this screen. Like, we'll use this screen a lot, so you guys might as well get used to it. So this one is just like a scatter plot. This one makes like an actual graph with a line, so it would connect all those dots. This is a histogram. These two are box and whisker plots, and we'll get there in a minute. But this is the one that we want. We put everything in L1. The frequency is 1. Mine is blue. You can change your color. It doesn't matter. But then zoom 9 is what we will always use. Zoom 9. So that makes a histogram. If we look at the dot plot though, trying to get it without showing you the answers to the rest of the stuff. It looks like that. Can y'all see it at the bottom? I'm trying. Okay, you can see it at the bottom, right?
Yeah.
So tell me what this looks like. So how can we describe this? Or tell me what you see.
I see left and right outliers on both sides.
Okay, we're not at outliers yet. Let's talk about shape, but we'll get there. We'll get there. You are not wrong. What do you think this shape looks like?
Like
This
a
is our-
stretched out triangle.
Okay, so
A
is it,
pyramid.
maybe, is it real pointy or you think it would be curved?
Kind of curved.
Curved.
How many curves would there be? So like you can say that we're in the middle, like we're in the very elementary stages of this. So we could say that this is like a hill. Yeah, everybody understand that? So that curve, a hill. How many hills would there be?
1.
1. Okay, so everybody kind of freeze that in your brain for a minute. Okay, I'll come back and forth to it if I can. So your shape is called unimodal. Why is it called unimodal? It has 1 hump. Okay. Where is that hump at?
It's like in between 25 or like high 20s and 30.
Okay, so it looks on this graph, and we'll eventually figure out how to do it if you guys look at those answers right there. It has a peak of 30, approximately 30. So it peaks at about 30. Then if we look at it again, what else is special about that heel? Forget about the outliers. Let's look at that heel. What happens?
Kind of drops off sharp on the right.
Goes down.
Okay, all right. So yeah, but that's what makes it the heel. But what happens within that heel?
There's a gap.
Yeah, there's a little gap. Does everybody see this gap right here? There's also
Yeah.
a gap here, and there's a gap here. So I'm just going to put right now that there are gaps in there. Sometimes those matter. Sometimes they don't. And then just to give you another thing to go by, most of your data is between 23 and 33. Okay. Where's your center? So like if we actually found that, your midpoint would be approximately 28. So what this means is a typical model year 2012 mid-size car in the sample gets 28 miles per gallon. Now, eventually we'll figure out how to find all those. So we're not trying to find them yet. So don't get stressed out because I'm not, oh my God, Ms. Jones, I don't know where you're getting these numbers. We're just guessing them right now. Eventually it's going to be set in stone. Okay. So don't stress out. What is your spread? How far did the data spread? You can look at the chart and figure that out. You don't need the graph. So look at the chart. How far did it spread? What's your smallest?
18.
What's your highest?
48.
48.
That's it. 18 to 48 is your spread. And you said there's probably some possible outliers on either end, and those outliers were 18, 40, and 48. And for now, we're going to call them possible outliers. You should always call them possible outliers unless you've done the math to prove that they are. Okay? If you say 18, 40, and 48 are outliers, you have to have the math to prove it. If you say that they are possible outliers, that just says, okay, we noticed that they're sticking out there, but we're not for sure if they're exactly outliers. I know that sounds crazy, but it's fine. All right, so now we're going to break it down and we're going to talk about just shape. So describing shape, that should have went on the next page. Right here. When you describe a distribution shape, so we're going to start getting into those specifics. So now by the end of this, you should be able to tell what shape it is. Okay, so before we were like, unimodal, it might have some gaps, blah, blah, blah. We're going to tell you exactly how to find it. Concentrate on the main features. Look for major peaks. Not for minor ups and downs in the graph. So even though that graph did kind of loop around in the very beginning, we're just looking at its overall hill shape rather than hills and hills. Okay, so the overall shape. Look for clusters of values. So that's where the unimodal comes in. We also have bimodal. It could have had two peaks. If it has two peaks, so it looks like camel humps, then that would be bimodal. And that would be clusters. There's clusters in this section and there's clusters in the other section. And obvious gaps. Look for potential outliers. Not just for the smallest and largest. So just because it's the smallest or because it's the largest does not make it an outlier. It makes it the smallest and the largest. You also want to look for rough symmetry or clear skewness. And we'll talk about both of those in just a second. Skewness. All right, so if you get a symmetric graph, the right and left sides are approximate mirror images. And that's that normal like hill shape we're looking for. So kind of like that. So your mean or your median would be in the middle and the left and right side pretty much look the same. Skewed to the right, you need to be careful on these because I think of them backwards, okay? Skewed to the right means that the right is longer than the left. That's the definition it will give you. But what I say is you're looking for the tail. So what's going to happen is you're going to have a graph that kind of looks like this. Okay, so this is the axis here. This one would have been like this. Okay, I think about this as a whale coming out of the water. Wherever that whale tail is, then that's where it's skewed. So look for the whale tail. Skewed to the left is longer than the right. So it's the other way. And your whale tail is on the left. So skewed to the left, skewed to the right, the tail is on the left and the tail is on the right. All right. For brevity, we sometimes say left skewed instead of skewed to the left. and right skewed instead of skewed to the right. Now the next part I never ever use, ever. But if you can think about it like this, then you can use it all you want to. We could also describe with a long tail to the left as skewed towards the negative values. Or negatively skewed. Again, I don't use that terminology, but if you see it that way, that's fine. If it has a right tail, it would be positively skewed. This next part is super important. Just like I told you up there, the whale tail, the direction of skewness. Is the direction of the long tail. Not where the data is clustered. Again, look for the tail. All right. Is everybody okay with this page? Can I move it? All right. Describing shape, figure 1.10, and I put that on here. It's these two dot plots right here. Displays the dot plot for two different sets of quantitative data. Let's practice describing the shapes of these distributions. Figure 110A shows the results of rolling a pair of fair six-sided dice and finding the sum of the up faces 100 times. So all they're doing is rolling it just like you'd roll for a board game. What is the sum of the two numbers that you see if you were doing the board game? The distribution is roughly symmetric. The dot plot in figure 110 B shows the scores on an AP statistics class first quiz. This distribution is skewed left. Okay, and we're going to talk about it. All right, so if we try to figure out the overall pattern and the overall shape, when we look at these dice rolls, you guys see it goes up like that one heel. That's approximately normal or roughly symmetric. Okay, that looks like a single heel. When we look at this one, we go up for a long time before we peak out and go down. That looks like that whale, and the tail is on the left. So that is why it's rough. This one's roughly symmetric and this one is skewed left. Is everybody okay with that? All right. Although the dot plots in the previous example have different shapes, so if it asks you for the shape now, you can tell me roughly symmetric, you can tell me left skewed, or you can tell me right skewed. It doesn't matter, just now you know how to do the shapes. They do have something in common. Both are unimodal, okay? What does unimodal mean?
It has one peak.
One peak. They have a single peak. The graph of dice rolls at 7 and the graph of quiz scores at 90. We don't count minor ups and downs. So like right here would be a minor up and down. these going, if I connected the tops, we don't count those as peaks. It's like the overall shape. Okay, so that's what it's talking about. And then we don't count them as peaks. If you look at the bottom figure, figure 1.11 is a dot plot of the duration in minutes of 220 eruptions of the Old Faithful geyser. We would describe this distribution's shape. What would this one be?
Roughly symmetrical,
Why is it roughly symmetric?
because it's just symmetric.
The same on both sides.
Yeah, it doesn't have the tail. So this is roughly symmetric, but what's different about this one?
It's bimodal.
Yes.
2.
And why is it bimodal?
2.
Two clear peaks. So again, the ones at the top are minor. These are like, look, there's clusters of data here, clusters here. Okay. One near 2 minutes and the other near 4.5. Although we could continue the pattern with trimodal for 3 peaks and so on. It's more common to refer to distributions with more than 2 clear peaks as multimodal. Okay, just like when you're working in algebra stuff, you have binomials, you have trinomials, and then they don't do it anymore. They do polynomials. So all that wanted to show you is if it had more, you would just call it multimodal. We don't really have any multimodal. We stick with single or double peaks. Okay. Any questions? All right, so we're going to check our understanding. Here's a dot plot. Can you describe the shape? I'm looking for 2 things here. Describe the shape.
It's right
Right skew.
Skewed to the right.
Okay, skewed right. Why?
because the tail's on the right.
Good. So if we graphed this, we can see a clear tail over here. I won't always draw those tails. I'm just doing it to give you a visual. One more thing.
It's got 1 peak.
1 peak. So that's called unimodal. Describe the center. What would
It's
this
like around
be?
2.
Okay. He says 2. Does anybody say anything different? You can debate. It's okay. So everybody agrees 2? You'd all get it wrong. Where do you think the center's at?
Would it be 1?
3 and 4.
I'm going 2.
Okay. Now realize when we talk about centers, even though we have whole numbers, like people have, the average family size that people have is like 2.5 kids. Can we have a 0.5 kid?
I mean, if you want,
No, you cannot. Don't say that. You cannot.
You
I don't
cut
even care.
it in half.
Midgets don't count like that either. Anything like that. I
Cut
know.
its legs off?
Thinking. Say what?
Cut its legs off?
Yeah, you can cut it in half.
It's still a person, guys. It's still a person. Remember, you're being recorded. This is going on YouTube. Be careful what you say. Okay. So if we describe the center, this center is actually going to be between 1 and 2.
So if it's a dot plot like this, is it always going to be the mean instead of the median?
We will learn which one you're going to pick. Center right now can either be mean or median. So right now we're going to stick with one of those 2. Okay. When we find out which one we use, then you'll know which one. So we're not quite there yet, but we'll
I have
get
a question.
question away.
Is it between 1 and 2 because that's where the hump is?
Well, that's going to, yes and no. It's going to determine close to where it's at. We will find out exactly how to do it. So if you had a dot plot right now, what you can do, how would I find the mean? How do you find the mean of anything?
average it.
Yeah, so we could average it 0 plus 0 plus 0 plus 1 plus 1 plus 1 plus 1 plus 1 plus blah, 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 plus 2 plus 2 plus 2 plus 2 plus 3 plus 3 plus 3 plus 5 plus 6. And then divide by how many there are. So we could find our mean. Mathematically, we could find it. Could we find our median? Yes, we list them out, mark them out, from one end to the other till we get to the middle. What happens if there's two middle numbers?
Don't you like add and then divide?
Yeah, you average them. So that's why this one could be between 1 and 2. So those of you that said 1 and those of you that said 2, you're not wrong, but we could possibly get a number in the middle. So what we're going to say is between 1 and 2 to cover all our bases. Eventually we'll know which one we're looking for and exactly how to find it. All right. So one more time, since this is skewed, we typically use the median, but we will go over that again. So put that in the back of your mind for a minute. Describe the spread. How far does it go?
7.
Does it go to 7?
0 to 7.
Say it again.
From 0 to 6.
0 to 6. We don't have any dots on 7. This is called the range. You guys know that. So 0 to 7. Are there any potential outliers?
Wait, is it 0 to 6?
It's 6. 6.
I'm sorry, 0 to 6. Thank y'all. 7 is not included. I said that. Thank you. What are your potential outliers?
5 and 6.
Wait, how are y'all finding the outliers again?
Which ones are far away from the graph, the actual data? So this is
what-
a big clump of data.
Yeah.
It makes a tail. These are always going to be possible outliers.
Oh, okay. Gotcha.
All right, I have less than a minute. I think we're gonna come back in and at least finish comparing distributions, okay? So if it goes out, we're coming back. So some of the most interesting statistics questions involve comparing 2 or more groups. Which 2 popular diets leads to greater long-term weight loss?